Hello everybody, this is the CIS 150 week 6 video. At this point you should have already went through chapter 3. There will be a chapter 3 quiz on Brightspace this week. It was asked if quizzes, exams, projects, things like that are cumulative, and by nature in this course it is cumulative. So everything in this class all the way on, if you're a computer science, to 250 is considered cumulative, because I can't ask you to write a program in 250 and not have you use variables, which is one of the first things we learned. So in that regard, it is cumulative. So just so you're aware of that. So on the quiz, you might see things referencing variables or input or output, things like that. But I do try to stick to as much of the new material as possible. What we're going to, like I said, there is a quiz out there. I am not going to give homework this week, but I am going to give another homework next week. If you've heard from people, this is the quote-unquote hard assignment that I give. I think that there are lots of benefits from the assignment, and when students finally graduate from this course, I read all the reviews that you guys do, and one of the main things that I get is, hey, keep that assignment. I know I hated it at the time, but that assignment taught me so much. And I get that from a significant amount of students. So what I'm trying to say is, next week, yes, you're going to get an assignment, and that assignment is going to be difficult. You will have to put in a lot of work during the 2 weeks to get that assignment done. What I'm trying to do by saying this is just kind of get you mentally prepared. Maybe you have work obligations that you can kind of set things up in the weeks to come so that you can have a little bit more time to work on stuff. I know that's what I did when I was in college, so I know the same struggle as you guys, full-time student, full-time worker. I agree. I was there too. So I understand where you're coming from. On week 7, like I said, that's when you'll get that quote-unquote hard assignment, and it will take you a lot of time to complete it. Okay? So if you waited until the last minute on the first assignment, hopefully you are going to heed my warning here with that you're going to have to put in quite a bit of time. Okay? So what we're going to cover today is chapter 4, and this is where it becomes fun, in my opinion. This is where we're starting to actually look at a quote-unquote programming language. Okay, so a lot of people, when you ask them, you say, hey, do you know programming? They say, yeah, I learned HTML and CSS once. Technically, that's not a programming language. In order for a language to be a programming language, it has to have two things. Those two things are the ability to make decisions, which is right here, and the ability to loop, the ability to repeat something. So at this point, making decisions, I hope that we start to get some wheels turning. We start to think about how powerful programming languages are. Then take it a step further when we get to chapter 5 and we start to talk about repetition. We really start to see the full benefit of a programming language, what we can do, what opportunities we have, and I guess start to look to the future for future courses and things that you want to accomplish. Okay? So chapter 4 typically takes us about 2 to 3 weeks because I need to set a good foundation when it comes to making decisions. Okay, the making decisions, if statements, will not go anywhere. And what I mean by that is, when you go on and take my 267 course, which is game design, you still have to know if statements. Okay, same with looping and repetition. Those things, all of those things stay the same from language to language. So it is critical that we set a good foundation here. Okay. One of the things that I hear sometimes from students is when I walk around and help, okay, and say that we're on week 2 of if statements. And I sit down and I look and I say, hey, you need a little more help with these if statements. And then I hear, well, I just didn't get chapter 4, but I'll be good on chapter 5. Do not fall down that rabbit hole. The reason is because if you do not understand if statements, you will not understand loops. We have to make sure when we are done with chapter 4 that you understand if statements. You understand how they work, you understand when to use them, and you understand why we use them. Okay? And I know I've been talking for 5.5 minutes. We'll get into some of this stuff, but I'm trying to treat this as if I was on grounds, and this is the same lecture that I would give on grounds. I always give this intro lecture for making decisions on if statements, okay? So if you have any questions about this, if something doesn't make sense, please send me an email. If you think we should do a live lecture, send me that email. Go on some kind of discussion post that I've put out there and say, hey, I think it would be beneficial for me and other students if we had a live lecture. I am more than willing to do that. But I have not heard anything after the last live lecture. Okay? So I think we'll most likely get to slide 25. I don't think we'll get to 4.5 just because there's a few things that we're going to have to cover. And like I said, I want to really take our time with this so we can have a good foundation as we continue to move forward. Okay? I'm going to go ahead and load up Visual Studios. And we're going to go ahead and make a new project. So I'll say create new project. And we want a console application. We'll say next. CIS 150 underscore the date. And then we will call this if statements 01 because I know we're going to have a few of these. So that's why I'm putting the 01 after it. And we'll go ahead and click create. One of the things that I want to cover first, and I know it's not in the slides, and I also know that we talked about it last week, last week. I'm starting to get my weeks are running together, if you haven't noticed. But we talked about this, and what we were talking about was the different types of CN statements, okay? And one of the CN statements that we... and I'm just getting this ready here, that we talked about was the get line, okay? And we use get line, and I'll just put a little comment here, say, looking at get line, and then I will also just say something like, get line, is used, I guess we'll say, is how we can read input that contains white space characters, okay? And I will just put the divider in there. That way, hopefully you can see a little better. And I haven't gotten any feedback on that, so I assume that everything's good with the way that I'm making these examples. I think you guys also have an advantage that you can rewatch these videos and you can also code it with me no matter how fast or slow you type. So one thing that what we're going to do here is just say string, and we're just going to say sentence, and we're going to say cout, enter a sentence. Couple things here that I want to discuss. First thing is it was brought to my attention, I can't remember the student's name, but I do appreciate all the feedback, that their code was running although we didn't include string. I did my research on this, and from what I have learned is it comes down to your IDE. Okay, Visual Studios is handling this for us, and from what I have read, IOStream, sometimes when you include it, once again depending on the IDE, string is already included through IOStream. So just something to be aware of. If you start to use a different IDE, and you're not used to including string, and you get some kind of error down here, just kind of remember this discussion that it might be because you have to include that in that specific IDE. Okay, so we're asking the user to input a sentence. Well, one thing that we know about sentences is that they do contain spaces. So we cannot use just a regular CN statement. Okay, if you use a CN statement, CN will read up until the white space character, and that's it. So what we have to use is getLine cin, and we will say we want to store this inside of sentence. Okay. We get a red underline. Identifier getLine is undefined. I am pretty sure that that is because we have not included string. So there is, and this is, I'm trying to learn this with you guys too, because as everything updates, I also have to kind of learn it. That's one thing that I always tell computer science students as well, is if you don't like learning, I don't know if computer science is the right field for you. Things are always changing in this field, so we always have to be learning, and we always have to be knowing new languages, new packages, new include statements. So here's another thing that I'm learning right now is getLine is housed in include string. So if you're using getLine, you have to include string. I would put that in my notebook. At this point, we're just going to see out the sentence. So we'll say see out sentence, and we will put an indel, and let's go ahead and run that. Hello, this is a test, and we do get hello, this is a test. That shows us that what we keyed in, we were able to save inside of a variable called sentence. That's good. Okay. The next thing that I want to look at in regards to input is cin.get. I'll give you a hint if you're listening. I always ask this on a midterm or on a quiz. Cin.get will most likely be on a quiz or a midterm. So cin.get is used to allow input for a specific char. And then we'll also say cin.get can read white space characters as well. Okay, so this is a little bit different because it will only take one individual char. So maybe you say, what, I don't know, what's your middle initial, right? And you only want to take just one char. Maybe this is what you use. Very specific in how you would use it. Oops, I don't like that. But it does exist, and there is a time and place for it. So we will say something like char character, and then I'll say cout, enter a single character, and then we will say cin.get, and then inside of the parentheses you say where you want this actual character to be stored. And I say I want that to be stored in character, the char variable that we created. So I'll say cout, and then we will, oops, not quotes, we'll just say character with an indel. Go ahead and give this a run. And we can hit A, and we do get A. Okay? One thing to be careful of is what happens if they enter more than one character? Well, what we have to know is that if they do this, this will most likely break our program down the road. And that's what we're going to get to next. It's when you start to mix your CN statements, you can potentially start to see some weird things happening. The reason is this. The user inserted ASDF. But because we are using cin.get, what we say is, I only care about the first character you entered. Whether you entered more or not, I don't know. I'm not sure. Well, what happens to the SDF? Technically, what happens to those three characters is they get stored in the buffer. And remember, the buffer is a way that we can store key input, keyboard input, and not have to be reading if keys were pressed or not. Right? Think about if you're waiting to see if a key was pressed. That sounds kind of resource heavy. Okay? So these three are now stored in a buffer. So what we want to look at next is when you start to actually mix these two. So let's go ahead and put another comment in here. And we'll say looking at mixing cin, and I know I'm saying cin.get in my first example. We just won't use cin.get very much. So the whole thing of mixing them together, it relates to cin with getLine as well, okay? So there is a general rule of thumb, and I will say the issue is when we use cin before getLine. That is the problem, okay? You can do the flip. You can use getLine first and then cin. But if you use cin first and then getLine, there is a problem. And let's take a look at that. So let's just say cout, and we will say enter your favorite number. Well, what input do you want to use for this? It can't be get, okay, because what if your favorite number is 120? Or more realistic, what if your favorite number is 12, right? Just 2 digits. That's a problem. You could use getLine, but the issue with getLine is getLine only works with strings. So do you really want to store the favorite number in a string? I'm not sure. What if I asked you for their favorite number and then add 10 to it? Well, if you stored it in a string, now you have to go out on Google and say, how can I convert a string to an int? So for me, it's going to be an int, and we'll call it favnum, and then we'll say cin into favnum. Cout, favnum, one step at a time. I know I said that in the live lecture, one step at a time. I know we're going to try to go on and do some kind of getLine thing, but I want to make sure that I can do this first. Does this work or not? 12, we see 12. That's good. Our favorite number is stored. Okay. The next thing we're going to say is let's ask them to enter their full name. So we'll say string full name. And I'll say cout, enter your first and last name. For this, can we use cin? No, because my first and last name are going to be separated by a space. Can I use cin.get? No, because if I do that, all they'll pull out is the z. So what we have to use is getLine. GetLine, cin, comma, and then where you want to store it, which is full name. The next thing that I want to do is, once again, let's just make sure that we can see if this was stored. Sure, maybe the final output needs to say this. Hello, Zachary Moore, your favorite number is whatever they put in there, right? 12. Sure, I agree. That's the final output, but I don't think you're ready to put all that together yet. We got to take this thing one step at a time, okay? So what I'm going to do is just say cout, full name, with an endl. So let's give this a run. Let's say, once it loads, favorite number, we'll say 23, and nothing happened. Okay, it didn't ask me to put my first and last name in. It just cycled through automatically without waiting. Why do you think that is the case? What is happening? The issue is, once again, when you mix these two together. Mixing cin with getLine. The issue is when we use cin before getLine. Well, we've done that. So we have a problem, and how do we fix it? The question would be, when we input this, what is actually being entered and stored in the buffer? Okay? So they enter the number 23. What is actually being stored in the buffer? Is it just 2, 3? Or does it look something like this, 2, 3 \n for new line? And it 100% looks just like this. Why is that a problem? Why is saying 23 \n for a new line, right, just like an enter or an endl, why is that a problem? The problem is because getLine can read any white space character. Remember, we're not sitting waiting for keyboard input. That's too resource heavy. What we do is we read the buffer. And the buffer says, or any of these inputs say, if there is something in the buffer, that must be what the user keyed in. That's true some of the time, but not all the time. In this case, it's not true. It reads 23, and because I'm CN, I don't read white space. So 23 \n. Actually, let's put this down here because that is where it's happening. We'll say 23 \n, and we'll say this is currently in the buffer. Okay? At this point, once it gets stored, we say that \n is currently in the buffer. Can getLine read \n? Yes. That is the problem. It assumes that what you keyed in here was \n for your name. So the rule of thumb is when you do this, the issue is when we use CN before getLine. If you use CN before getLine, you must include, I don't want to say include because that gets confusing with if we're including something up top. You must use CIN.ignore between them. Ignore what is currently in the buffer. I'm going to delete these comments, right? You should be able to take some notes from those, but I think if I leave them in, they will be more confusing. At this point, before you read getLine, you have to say CIN.ignore. Ignore the next thing in the buffer. Ignore it. Delete it from the buffer, right? However you want to look at that. So now let's go ahead and say 23, enter, 23 \n is in the buffer. Ignore the \n. I don't need that. Now put in your name. Look at that. We have both things now working together. So now I can concatenate this output. I'm going to comment this out like this and comment this out here. And then we'll concatenate this output and say the string literal hello with full name. Your favorite number is concatenated with favnum and an endl. Sorry if you're hearing jingling. That is my dog walking around. And we'll go ahead and give this a run. We'll say 23. And we get hello, Zachary Moore. We forgot a little space here, so we can fix that easily. Your favorite number is 23. So put a space here, and we're good to go. Okay. The buffer is kind of it is a tricky thing to understand. Okay. I understand that it is tricky. That's why I kind of give you this rule of thumb. If you use CN before getLine, you must use CN ignore between them. Okay? I'm going to go ahead and comment this out, and we are going to move on to the Chapter 4 material. So let's pull up the slides and start to look through some of it. Relational operators. In if statements, what we're talking about is comparing things. Okay? If this happens, then do this. It is no different than like today. Right? I think it's supposed to rain today. You guys won't know because it's a random day that you're going to watch this. But I think it's supposed to rain today. So I say, if it's supposed to rain, should I maybe take an umbrella? If it's going to be cold outside, should I maybe take a hat? Should I maybe take gloves? Should I maybe take a jacket? If it's below 30, I need a jacket. If it's below 20, I need a jacket and a hat. If it's below 10, I need a jacket, hat, and gloves. You do this every day. Right? We do this every day, whether we see it or not. This is something that we cycle through. Our mind works in this manner of if this, then that. If this happens, then do this. If this happens, then do that. Okay? So some of the ways that we can relate to this are with, like I said, these relational operators. Greater than, less than, greater than or equal to, less than or equal to. These things we should all be comfortable with just from working with math. Okay? Equal to and not equal to. This happens all the time. I am telling you, you will lose 45 to 50 minutes of your homework time because of this. You will put a single equal sign in your if statement. It will not work the way you think it does. Put that in your notebook. Okay? It will happen. It is very easy for that to happen. 2 equal signs is to compare. 1 equal sign is for assignment. Right? Like assigning the value of 20 to a variable. And then not equal to, this is the one that is very inconsistent between languages. But for C++, it's exclamation point equal sign. That means it's not equal to. You can look at some of these expressions here. But in the end, what we're trying to get to in regards to relational expressions is this true or is this false? Okay? Is this true or is it false? That sounds like a variable that we learned a little while ago called a Boolean. You don't have to. Okay, you don't have to use a Boolean. But it might help as we start to go forward. One of the biggest spots that I see a Boolean is in games. Right? Is the game over, yes or no? Should I continue to do this because the player is continuing to play? Yes or no? Okay, that is a good way to have a Boolean. But for right now, what we're going to do is we're just going to throw expressions like this in our if statement and see what happens. Okay, so let's pull this up, and we're just going to put that comment header again. And we're just going to put everything under this comment header from now on. We're just going to say looking at if statements. And let's just say that we have a number, and I'll say int num, and I'll say that that is equal to, let's just say 10. Okay? For simplicity, let's just say if num is equal to 10, see out the number is, let's not do that. Let's just say, let's just say see out the number with an end out. And let's give this a run. And then I'll come back in and maybe put a few more comments in there. So we do see the number 10. Okay? We do see the number 10 here. That's because num is equal to 10. Notice the syntax here. If, open paren, close paren, no semicolon. There is not a semicolon after this. If you run this with a semicolon after this, you will get very weird results. Okay? It basically is going to fire every time, no matter what this number is. Is 100 equal to 10? We said the number is 100. Is that equal to 10? Absolutely not. In what world is 100 equal 10? It doesn't. But we're still seeing that. That is because there is a semicolon there. It's telling this thing that that's the end of this if statement, and that's not true. Run this again, and we should not see anything. Nothing is produced because 100 does not equal 10. Okay? In the book, you will see them put brackets like this. There is a debate between new line brackets or same line brackets. I am a new line bracket person, meaning that you will see all of my code like this. And the reason is, and I know that this is going to get complicated, but I just want to show you an example. As we move forward, we will have statements that look something like this. If this, if this, if this. And this if statement has to be nested in this, which has to be nested in here. If these are all same line brackets, I find that harder to line up and understand what's nested in something. It is a personal preference. I do not care which way you do this. But for all of my work that I show you, I will be showing it with new line brackets. Okay? What we're saying is that any let's just say any code in between these brackets will only execute if, let's say I hate to say if, but I think that's what we're going to say. If the if expression evaluates to true. We'll just say cout again with num, end and end L. This does not evaluate to true. This evaluates to true. That means if it's equal to 10, you can display the number. Okay? One thing that I like to ask is the statement like this. How many times will this if statement evaluate to true? Say that we let the user put the number in. Okay, we say cout enter a number. We'll say cin into num. Do we agree that they can put in any number they want? I hope we all said yes. Given any number that they want to put in, how many times will we break into this if statement? One time and one time only. That is only when they key in the number 10. Do you agree with me on that? I'm pausing as if you're going to say something. I'm giving you time to think. Hopefully you agree. This will only ever evaluate one time. How many times does line 54 evaluate to false? They can key in any number they want. They key in 50. That's false. 50 does not equal 10. They key in 100. 100 does not equal 10. How many times does it evaluate to false? Infinite. It evaluates to true once and evaluates to false infinite times. Meaning no matter what number they put in, as long as it's not 10, this will evaluate to false. I'm saying this because we will need to utilize both of those. I want this to evaluate no matter what number they put in, as long as it doesn't equal 10. Okay, so if we do the flip of this, we say does not equal 10, how many times does this evaluate to true? How many times does if num does not equal 10 evaluate to true? It's just flipped. This is infinite number of times. You put in 100, that does not equal 10, that's true. You put in 50, that does not equal 10, that's true. You put in 1,000,000, that does not equal 10, that's true. So on, so on, so on. And how many times does this evaluate to false? One time and one time only, and that's when they enter in the number 10. we have to utilize that logic to our advantage. Okay? We have to be able to utilize that logic to our advantage. Okay? So let's go ahead and comment this out. And what I want you to do is I want you to pause the video. And what I want you to do is write some kind of statement that would say, ask the user to key in a number. So we'll say this. Let's do this. Ask the user to enter a number. If the number is less than or equal to 10, tell the user that is a good number. If the number is greater than 10, tell the user that number is too big. Okay? Use the slides, use the work that we've done, and try to come up with this. It's the user for a number. If the number is less than or equal to 10, tell them it's a good number. If the number is greater than 10, tell the user that the number is too big. Pause the video and come back in, let's say, 20 minutes. Okay, hopefully you were able to get that done. If not, let's break this down. Okay? The first thing I see is I need an int. We'll call it number because the user is going to key something in. I say cout, and let's just say enter a number less than or equal to 10. Cin into number. At this point, we know we have to use some kind of logic because we're saying if. A lot of times that will give it away on my directions. I have to use the word if. If they do this, then do that. Okay? So what we'll say is if the user, whatever they keyed in, which is number, if they keyed in a number that is less than or equal to 10, then we want to say cout you entered a good number. If for some reason the user did not follow our directions and they key in a value that is greater than 10, we will say cout you entered a number that is too big. And I don't care what you put in here, right? I always hear that in class. You didn't say exactly what message to put there. That's not what I'm grading you on. I don't care. Put whatever you want in there, okay? So my next question is this. What is the minimum number of times that you can test this program to guarantee that it works? It's a tricky question, but I see people do this all the time. They'll say 10, and let's say you entered a good number. My code must be right. How can you tell me that? How can you say that? And I typically can pick this out. And I'll say, how many times did you test this? Oh, a bunch of times. Well, at this point, you haven't tested this a bunch. You have to at least test something that would hit here and then something that would hit here. So the minimum is 2. But I would prefer if you tried 2 numbers in here. When I test your programs, I'm going to throw 5 numbers in here and 5 numbers in here. I'll go 5, 6, 7, 8, and I will 100% hit 10. Why? Because it's right on the edge. You got to make sure you coded that right. Here I'll enter 20, 30, 40, 50, something like that, and see what happens. If you're getting the right messages, at that point you can call it good. But to just throw the number 10 in there and say it's good is not correct. You entered a number that is too big. Okay, let's bounce back to the slides because this is the way that they show an if statement. They don't show the brackets. Okay, and that gets tricky. And I don't want to show. I hated in school when they showed you something just to go on 4 slides later and say, yeah, but that's not the way we do it. Like, why did you show it to me then? So this is a way that you can accomplish this. You can do it just like this. But what if I said that if the number was 10, add 15 to it? Okay? If the number is 10, add 15 to that number and then display the number at the end. So we'll say something like this. Number is equal to number plus 15. What's another way to write that? How else could we write this? Number plus equals 15. Remember, plus equals is the same thing as writing this. I don't care which way you do it, but there are 2 ways to show this. And I'll say same as above. And we'll say same logic as above. But the issue that I'm trying to get to is if you do this and you don't throw the brackets in, what you said is you only want to execute one thing if this evaluates to true. So if you have one statement, sure, you can do this. However, if you have anything more than one, then you have to throw the brackets in. I find that annoying to teach you this just to turn around and show you 3 slides later that they're actually going to use the brackets. Okay, so that's why I'm not showing it this way. If you want to do this for single line statements, that's fine, but you will never see me do that. I will always throw the brackets in. Okay, so now let's go ahead and see out number and just make sure that this works. And then down here, I'll just say, tell the user that the number is a good number, and add 15 to that number. And we'll go ahead and run that. And we'll say 10, and we get the number 25. You entered a good number. You entered a number that is too big. That's really interesting. Why is this happening? Why do you think this is happening? Go on a few slides ahead. Expanding the if statement. Shows the brackets. And then 4.4 shows something else. If-else statement. And some of you already might have done this. Okay? But the question you have to ask yourself is why would that happen? At the beginning, we put in the number 10. Is 10 less than or equal to 10? It is. Jump down, do this, add 15 to it, the number is 25. You're doing another comparison here. Is 25 greater than 10? It is. So then I'll also tell you that you entered a number that is too big. So I always get asked this question. Why would I use an if-else chain instead of multiple if statements? Well, the answer is this. If you use an if-else chain, only one of the statements will execute. If you use multiple if statements, let's put a comma there. Multiple statements can execute. I can't say that they all will. All I can say is that they might. Multiple statements, let's say multiple statements could execute. Could. right? What if I deducted 15 from it? This one wouldn't fire off, right? So how can we fix this? Let's comment this out. Actually, what I'm going to do actually is just copy and paste this and then throw it below, because I know that the code's going to be very similar. And what I'm going to do is then just comment this out, Control KC, and then copy and paste this header. And we will throw this in right here. So what I'll say is looking at if, and we'll say if else statements, okay? And what I want to say is this. I don't want both of these to fire off because that's not true, right? The user keyed in a good number. What I do after the fact is that's me as the coder. That has nothing to do with what they keyed in. So let's go back to the slides. Provides two possible paths of execution. Performs one statement or block if expression is 2. Otherwise performs another statement or block. But we know that we can only ever fire one of these. Only one will ever fire off. Okay? So what I'm taking this a step further just because it's not too hard to look at it this way. We could easily say this, if, and then we could throw in an else. Okay? And that says if it's less than or equal to 10, else it's any other number in the world. That works in this specific case because of the whole thought process of how many times does this fire off versus how many times would this. It says if it's anything other than 10 or anything that's greater than 10, fire this. Another way, and I'll say this, cannot be an if statement because it will execute after we increment the number. However, it could look something like this. So I'll put an or it could be else if number is greater than 10. And it's going to throw an error because I have the else and then the else if. Okay, so I'm going to go ahead and comment this out. And let's try to diagnose this. If the number is less than or equal to 10, else if, because this is in a chain, an if-else chain, we know that only one will ever execute. It will be critical on the homework that you understand when to use if versus if, else if, else. I will make sure, and not will, I have made sure that the homework will have you use a combination of the two, and you have to know where to use each one. And if you can't figure out where to use each one, you cannot get the homework done. That is a fact. Okay? So let's go ahead and run this and make sure that both of the else and the else if work the way that we thought. So we'll say 10, and then we do get you entered a good number, and then 25. So this got completely skipped. Although the number was 25 at this point, it got skipped because only one of these can ever execute. Let's make sure I'm not a liar. We'll put else in there, and we'll make sure that that executes. Put in 7. We get 22. That's good too. Okay? I'm always asked when should I use if or else if. I'm sorry. If, else if, or if else. I cannot answer that question. The reason that I can't answer that question is because it depends on what you're coding. Right? It 100% just depends on what you are coding. It depends on the logic. Once we get to if statements, I start to see a ton of different code. Right? You used if with nested ifs, and someone else used an if-else chain, and somebody was just using multiple ifs with a bunch of Booleans. That's fine. I see tons of stuff, and I can't tell you how to do it. I can help look at your code and tell you if you're in the right direction, but I cannot tell you how to do it. Okay? So, next little assignment I want you to do, and this will be the last thing we do. I'm going to copy this, and we're going to relate this to the homework. Not the new homework, but the past homework. And we'll say, looking at if else again, we'll say, ask the user to enter their first name. Next, we'll say, if the user has a name that begins with a B, tell them the first letter of their name is B. If the user has a different first letter for their name, tell them the first letter in their name is not a B. I know that the displays are kind of weird, but what we want to do is ask the user for their name, look at the first letter, and make a decision based off that first letter. This is where it becomes cumulative, because I already showed you a function on how to look at letters. You should know how to find the first letter, and you should be able to use the if statements to figure that out. Okay, look at the slides, because at this point we're comparing chars. Look at the slides for some help. Take 15, 20 minutes to work on this one as well. That one was a little bit harder than the first one, okay, just to be clear. But let's go ahead and take a look at this. I hope some of you were able to get that done. So we'll say string, and we'll say name. I don't know why everything's getting justified all the way to the left. I don't like that. That's weird. And I'll say cout, enter your, we'll say first name, and then we'll say cin into name. Why can I use cin? Because, well, I guess I can't say for sure. There could be spaces in people's first name, but we're saying for the sake of this, there isn't. At this point, I have the name, and now I need to look at the conditions. I need to say if your name, the first letter of your name dot at position 0, if that is equal to, in the way some people will do this, and it's not going to work. It has no idea what a B is. It does know what that is, though. Okay, it 100% knows what that is. This is a char, correct? It is one letter from a string, which is a char. So is this. Comparing a char with a char. This gets students tripped up a lot, is understanding what this on the left side is and what it needs to be on the right-hand side as well. Okay, so I'll say cout, the first letter of your name is, and we'll just say B. We'll hard code it in there with an indel. At this point, you have two paths. The first path is else. Else, meaning it's any other letter, because you can read this and say, if the user has a different first letter for their name, tell them, and we could say in there, if they have a different first letter than a B, meaning any other letter in the alphabet other than a B, that sounds like an else to me, cout, and we'll just say the first letter of your name is not a B, with an indel. Or else if name dot at 0 does not equal a B. If it does not equal a B, then this is what I want. And it gets all thrown off on this because I have the else up here and the else if. So you can't do both of these. Okay? You can do something like this if, and we'll say else if, else. And that chain can go on for forever. If, else if, else if, else if, else if, else. A few spots where students get tripped up. That, you'll run the code and it'll say there is a missing closed bracket. Okay, you're missing a closed bracket somewhere. It comes with practice, to be honest, to not have those. When I first started out, I had them all the time, and now I rarely get them because whenever I make an open bracket, I make sure to close it immediately. That is the best way to do it. The other spot where students get tripped up is they will put this here. And there is no condition for an else. It means anything other than that. Anything other than these two conditions will go to here. Okay? So let's comment this out. And I will just put some kind of header here looking at an if-else chain. So let's run this. Say, Bob, the first letter of your name is a B. We'll say, Jeff, the first letter of your name is not a B. What happens if we do this? The first letter of your name is not a B. Why? It is a B. You told it to only look for capital letters. That's what you said here. It doesn't know that an uppercase B is the same as a lowercase b. You have to code that in. And we'll get to that next week. Okay? If you have questions about the lecture, please let me know. Post them on the discussion board. Shoot me an email if you need me to look at your code. But like I said, this week there is no homework, but there is a quiz for Chapter 3. Okay? If you have questions, like I said, let me know, and I will see you in the next video.